Okay, welcome everybody to Robot Builders Night Virtual for December 17th, 2024. We'll do the usual go around the queue and then open it to open mic, stump the club, and any questions or discussion or new discoveries anyone may have had. So let me ask first for anybody in the queue who has something to report on. Tom. And
I have something too.
Doug.
Yeah.
And myself. Anyone else?
I could share something.
All right, Kareem. Excellent. All right, Tom, what you got?
Okay, let me just share a little screen here. And it looks like I want to share this one. This is several very, very quick updates on some things I've been doing in the last week or two. The first one, at the risk of boring everybody in my GSG stuff, just one slide.
Boring.
I've continued to test my ability to refine GPS accuracy. So this is simply a combination of 4 different tests of dispersion information. This is the test routine I've been using. I have a local origin situated in my back patio, and then I take my robot out and put it down and hold it stationary out in the front yard where I can see more satellites. And I've run 4 tests here. The first one is the green one, and it has no grounding, just my traditional Neo 6M GPS with no grounding. You've seen this curve before, and that's the green one. Then a day or two later, after I had added the ground plane to the GPS antenna, I did this again, although I picked a different stationary point. It's about 5 meters farther north than the green data set. So the other 3 data sets are 5 meters away. That's why they're offset on this curve. So the blue and the red and the yellow ones are all in the same place, the same stationary location. The yellow one showed 6 satellites with a partial ground. Basically, I had a 4-inch ground plane not grounded to the ground of the antenna, unfortunately. So that wasn't so great. And that was with 6 satellites. And these are all US GPS only satellites. Although, to be honest, I only ever see an additional 1 or 2 Russian satellites. Mostly I will see lots of GPS satellites. I'm just looking at the legend here. So that was the yellow one, partial ground, 6 satellites. The red one is full ground with 6 satellites. You can see we're getting it just a little bit tighter, not much. The blue one was with 7 satellites. It was taken about 20 minutes later, and there were 7 satellites running, so I grabbed another one. So that's probably about as good as I will ever get with the technology that I'm currently using with just GPS. But that's not so bad. Now that has caused me to begin the next phase of how to refine what my outdoor robot can find.
Excuse me, Pat,
Tom,
can I ask you one question? You
Go
said ahead. You've got an antenna out in the backyard, and then you sit the robot in the front yard. So
no, I have a local origin. That is, I've identified a GPS point, which I will use in the math as the local origin in order to convert the GPS measurements into XY coordinates, which is what this graph shows. So the horizontal axis, these are in centimeters. The horizontal axis, which is longitude, simply shows a number that's much easier to deal with and a number that's much easier to do navigation math with in 2 dimensions. And similarly, the vertical axis is simply latitude, but it's in centimeters.
So I have a question.
Yep.
So what we're seeing here is where it's showing where your GPS is at it's moving around, but it's not moving around. It's just
Right.
stationary, right?
The robot is stationary, and I collect the GPS data. Once everything is stabilized and I've got really good DOPs, or as good as I'm going to get, then I collect data roughly once a second for several minutes. And then I graph all that data, and that's what produces these lines that appear to be moving around. That's the natural dispersion of the GPS signals.
All right, that's good. Is that what's the radius of that? What how big is that? How
Yeah,
big of an area?
the dimensions on each of the axes are in centimeters. So for example, this blue line is 1 meter across.
Okay.
Okay. And it is 4 meters high.
All right.
The
So
red line is about 1.5, 2 meters across. And again, it's about 4.5 meters high. And that's over a sample time of about 2.5 minutes.
So does your Y correspond to latitude?
Yes, it does.
Okay.
North at the top.
Yeah. Huh. So that's weird. You get much better longitude than you do latitude.
Yes, I noticed that as well. Much tighter longitude than latitude. By a factor of about 3 or 4. Not really sure why. I did a little bit of research, but I couldn't come up with any conclusive answers. Focus groups and media stuff is all over the map on the reasoning. Other people have noticed the same thing.
Oh.
And I'm not ready to spend the big bucks on centimeter level RTK. So my next step was to move to some optical stuff. You may be familiar with this, ESP32 cams. I have several of them in my junk collection, so I thought I would brush them off and use them for something. The first thing I did with them, these are nice little units.
Mm-hmm.
The first thing I did with them was some orange blob detection. This is kind of cheating a little bit. The webcam's collecting all the data. The data gets sent over my local area network to my desktop computer, where OpenCV.js processes the data on this nice graphics display and then sends the results back to the ESP32. It was simply an experiment to get comfortable with how this stuff works. This experiment works really, really well. There is a version of OpenCV, a very limited version of OpenCV apparently that will run on an ESP32. It will only compile in the Espressif IDE, and I'm using the Arduino IDE at this point. So that may be something to look forward to. I'm kind of pleased with the results. I learned a lot. This is really, really easy to work with. So then I moved on to something a little more aggressive. This is the training results from using Edge Impulse, which supports ESP32 cams. I used Bob Cook's image set. Doug, I also have access to yours. Pat pointed me to it. But I thought I would stick with Doug's stuff, or sorry, with Bob's stuff, because it's a somewhat smaller data set that I have more familiarity with. This is not good training results yet. 75% is not a great number for confidence for score, but there's still some more work I have to do, I think, to clean up the data set I'm using. It's not bad. The learning curve is moderate for how to learn how to train in Edge Impulse for my target machine. My first result, the score was 0. So I've come a long way from 0. I have this model running on my ESP32 Cam standalone, and it's working surprisingly well on my workbench. So I'm pretty happy with it. I don't have any more slides to show you, but at this point, I'm working on adding a little graphics display to the ESP32 Cam because I found that it's really, really hard to figure out what it's looking at when you always have to go back and look at the serial monitor display from the Arduino development environment in order to see what it's spewing out. In terms of spewing it out, these results of training suggest less than 1 second to process a frame. That would be on the model that Edge Impulse recommends, which is it's an Espressif I, an ESP32 I model, which is a higher performing ESP32, and they recommend that you compile their output application with the Espressif IDE, not with the Arduino IDE. I'm using the Arduino IDE, and I'm using an AI Thinker ESP32 Cam, and I'm getting execution times of about 4 seconds. So that's not good enough yet. So I have some more work to do. We'll see what I can do to increase that from 4 seconds. But it is working, and it's working reliably. And I think I've spent a couple of half days on it so far. So it's gone fast. Any other questions?
Yeah, have you seen or ever heard of random nerd tutorials?
Yes, I use them a lot.
Okay, yeah. He had an example using, I thought it was a Java version of some CV routine. But I thought it all resided on the camera board, not on any of it was on a laptop. There was a web page you could look at.
Yeah, I think I've gone through all of his stuff that's ESP32 based, and I didn't see that.
Okay.
He has 6 or 8 different vision-based applications, but not that one that you described. But if I missed it, by all means, send me a link to it or post a link.
Okay.
The ones which run standalone, which of course is what I want to do, are few and far between. There are some. They seem to work well. We'll see how well I can make mine work, because I picked one of them and ran with it. DroneBot Workshop is where I started with some of the prototypes I was working with. The DroneBot Workshop guy is pretty good, and he's back again. He's appeared again on online. He was offline for quite a few months because of personal issues, but he's back up now.
And Tom, you said these are results of finding a cone or attempting to find a cone on an ESP32 Cam. What is an ESP32 Cam? Is it a smart camera where you can run AI models on the camera, or what is it?
The short answer is yes. The entire model is running on the ESP32 that's on that little board. The board has the camera. It has an ESP32. It has just enough additional I/O points available that I've been able to add an I2C interface as well as a serial interface. The serial interface they provide, and I added an I2C interface because I want to drive a display.
Just to clarify, the camera itself doesn't have a AI coprocessor on it. It's the ESP32 that's doing it.
Yeah.
There's no accelerator on it.
The camera sitting here, see if the part number's here. It's a conventional dumb 2 megapixel camera.
Yeah.
The ESP32 does all the work.
But they're very
Go on.
Sorry, I was going to jump in with a question. I was just wondering, so for the part of this project that involves AI, is it can you explain like which AI model you used and how does the AI model relate to the ESP32 camera? I mean, I'm assuming you're also using computer vision, maybe. I'm curious about that.
I can tell you what I know, which isn't a whole lot. The particular service I'm using is known as Edge Impulse. You can look up their website, edgeimpulse.com. They're basically providing a relatively easy and free mechanism for building a database of images, configuring the parameters of the neural network training that you want to do and the object you want to be able to detect, and then exporting the results of that modeling along with a code package that will run on the target machine you told them you wanted to use. My understanding is that they are probably using TensorFlow Lite, but I'm not sure. They make reference to several different compiler and neural network environments, but I believe this stuff is running TensorFlow Lite, but I really don't know.
Another alternative is RoboFlow.
Yes, I looked at that, but they do not support ESP32s.
Oh, no, but if you're wanting to train your model, RoboFlow has really a nice way for you to gather up your images and get them all put together.
I know that,
And-
Doug, I noticed that's where your models are, and Bob Cook has his models up there as well, as
Yeah.
well as YOLO.
Yeah, and they have instructions. I can't handle the link right now, but they have instructions where essentially you can take your model and you can access a Google online server, and it will take them and essentially train your model for you.
Now, just to confirm, Radia, did that answer your question, or was there more to it?
Yeah, that answers that. And then the next part is just about ESP32. I'm assuming that's kind of like a Raspberry Pi where you're running the model. I don't know.
Very light Raspberry Pi. If I can't make this work well enough, my next step up will be a Raspberry Pi with its embedded camera.
Yeah,
cool.
but Trish, it's not. It is different. It's more of a microcontroller as opposed to a single board computer.
Yeah.
Okay. So
32 bits, 2 cores, 240 megahertz,
yeah.
half a meg of RAM internally, and about 8 meg of PS RAM or flash RAM for code.
Right.
But
So
I think
it's equivalent to
the big
it's a
difference, Radia, would be that the ESP32, as Doug said, is a microcontroller and therefore runs an environment like Arduino or some other flavor of an embedded environment, whereas a Raspberry Pi will run Linux typically.
It'll have it'll run an operating system where those
Yeah.
microcontrollers
Yeah.
don't.
right.
Yeah. ESP32 actually comes delivered by default with RTOS running, but I don't believe that the TinyML that they're running is running under RTOS. I believe that it's running right on the middle.
Yeah, but you will find that so there's ESP32 is a really nice processor with real advantages. It's got a really nice Wi-Fi stack, and it also has Bluetooth. So, and it can be loaded up with MicroPython if you have Python experience.
Yep. It's also really cheap and extremely low power, which are two things I'm always interested in.
Right, it is cheap, and so therefore it's kind of like the new Arduino. Okay, it's the Arduino environment used in the ESP is one thing you can use. So so if you have Arduino experience, you can learn to do it. I'm going to talk about some books. And if you really want to learn about ESP32, the link that Ray suggested, what is it, Random Nerds?
Random Nerd Tutorials.
Yeah, that's a very good place to get started.
Yeah.
Like I
Also,
said,
have a look at DroneBot Workshop as well.
yeah, but the boards are really cheap. Like the ESP32 Cam board that Tom was talking about, and I think you can get 2 for $5 or $6. I mean, they're really.
Yep. And when you get one, I'm not sure how well you can see this in front of my camera, but there's 2 boards plugged together here. The ESP32 Cam is one of the boards, but it has no USB port. So what you want to do is get the other one. I have one here I'll pull apart so you can see the 2 pieces. I have a little 3D printed boxes to mount them in so they don't get messed up. Take this apart. So there's the ESP32 Cam itself. And what you want to do is get one of these, and this plugs into it, and it has the USB interface on it. And that simplifies life a lot. So get that as well.
I agree with Tom. And those are often sold together. And if you don't want any hassle and you don't mind a few extra dollars, you can pick it up on Amazon with not too bad.
Or AliExpress.
Yeah, AliExpress is cheaper, but you have to know more. And
wait a little longer for delivery, maybe.
Yeah. But you know, if you somebody find a link and put it in the thing, because I want to say it's $6 or $8 for both boards, and it's not very expensive.
Yep.
And then go to Random Nerd.
If you blow them up, it doesn't matter very much.
Yeah, and that comes with the camera. So if the ESP32 doesn't have to be used with a camera.
No.
But and
But applications, video signal processing.
Tom, is that a 2-core? You sure? I thought the Cam was a 1-core.
No, ESP32s are 2 cores.
No, but not all ESP32s are 2-core.
The ESP32s you'll find in basically everything today will be 2 cores. The early ones were not. And I think they brought out a very light version, which is only 1 core, but why would you buy it?
Well, that's what I want to say. Are you sure that the Cam?
Yes, I am sure. Yes.
Okay.
I am.
All right.
Yeah, it was made with the old, I called it the Dowdy. It's DOWD6, which I think was the dual core.
Yeah.
Yeah.
I can't see it in this, but yeah, I think that's what it is. It's dual core and it's called the S version. So ESP32.
Probably it's 3, maybe.
It's not a 3, no.
Oh, it's not a 3. Okay.
I wish it was. A 3
Oh,
is
just a plain
flat.
S.
Right.
Yeah.
And that's the other thing you find about Trish is ESP32s come in a gazillion flavors.
Yeah.
All right, but they're all 95% the same. So the only thing you're really trying to do is like that backboard that Tom showed you. If you get one of the big ones, you probably want to find a motherboard that you can put it into. And there's all sorts of different pin counts, and because they bring out different pins, and it's a little weird. But if you go to that Random Nerd, they will guide you very specifically for the right. They even list, like links that you can buy, and they show the current prices and everything.
Yeah, his early articles do not mention the motherboard, the USB interface, but his later ones not only mention it, but tell you to absolutely get one.
Yeah, it just makes things simpler to
Otherwise, you need an FPI USB to TTL interface, and you have to play around with plug wires.
Yeah, and if you accidentally put the 5-volt one on the 3.3 pin, kapow! So just buy the board and simplify your life.
Yeah.
So I was mistaken. There is a 1-core version of the ESP32 as well as a 2-core. I did not know that. I thought the 82, what's it called? 8266 was a single core, but I was wrong.
There's like a C6 now.
Yeah. You just have to be careful if you're buying from AliExpress. That's probably usually in Amazon they'll tell you, but in the AliExpress gives you one sentence, and if you don't recognize the name, you might get confused.
Well, cool, Tom. Interesting data.
It's been an interesting week, especially this learning curve for doing the machine learning development and actually having it work. I had to upgrade my Arduino development environment to the latest version 2, which otherwise I couldn't get legitimate compiles, curiously enough. I was running one of the 1.8s, which I haven't upgraded for years because of the problems that first occurred when version 2 came out of the Arduino environment. But the latest version, which is 2.3.4, incorporates some automatic makefile capabilities. So the first time you compile this application is very, very big. The first time you compile it on my desktop, it takes a long time, 20, 25, 30 minutes. The second time, it's down to a minute.
Yeah, I'm surprised, Tom. You're right. It does take longer to work with an ESP32, but 25 minutes, something's wrong.
The first time, well, yeah, but try it on one of these machine language environments. The resulting code that is produced is enormous and very complicated. First time, long compile. Then it builds the makefile information. And once it's got that, you're down to about a minute. I still look forward to moving back to my MicroPython environment where basically the turnaround time on iterative development and testing is about 9 seconds. So this is about, well, 1 or 2 minutes after I've done the first compile, if I don't mess around with any of the make files.
So next up was Doug, but we got one new person, Radia, and Trisha's joining us. So just for anyone who doesn't frequently attend these calls, please know that we don't use the raise hands very much. Feel free to just jump in and ask questions interactively. Okay, Doug was up next.
Okay. First, I want to address a few things that people had brought up that I thought just because they happen to be something that I had seen recently. Let me try to present. Okay.
In 1999, Appeal developed and released app.
And so this is first one. Tom mentioned about programming and the IDF. This has literally been just, I'm not sure exactly when it came out. Okay, October. And Harry Fairhead is an excellent writer. He has a series of books about the ESP32 and other topics, but Raspberry Pi, for example, and he's a big C programmer, though he does have some Python titles. But anyway, this just came out, and I thought that might be something somebody might be interested in. Then the second thing had to do with, I looked into one of these, and I really can't, I can see it's no longer available. And I also looked it up on the web, and it looks like the price went up. But this is a 4-pole, they have, what's the antenna for, it's supposed to be 7 bands and a few other cool things. But the nice thing about this type of GPS antenna is you don't need a ground plane. And so also Scott uses one of these, by the way. If you look on, I can't think of what it's not. One of his robots, the one that did better, he has one of these on it. Not this, but a similar antenna. So that I thought Tom might like, to take a look at this and use the description here to see if he can find.
Doug, is it an active antenna?
I don't think so.
Or it's just a 4-pole helix?
Yeah, it's 4-pole.
I looked at building a helix, but I couldn't see any advantage from a gain point of view. It eliminates the ground plane, as you pointed out.
Right.
I was going to get one of my RF buddies to build one for me, but it didn't look like it was worth it.
They actually do worse. If you look up SparkFun's articles on it, if you're space constrained, it's recommended, but they'll clearly say that if you want best results, use a regular antenna with a ground plane.
Yeah, I'm just saying this is another option. I've got one and I'm playing with it right now to see what it can do. And
I swear it looked like without seeing the title on the right, I first thought it was a nose hair trimmer when you brought it up.
Yeah. Well, it's upside down too.
Yeah, I know. Yeah.
And I was pointed, and this one is actually pointed down.
This one I think is powered. It says the third bullet says it's got a low noise amplifier, and the fourth bullet says it's got low power consumption.
It's got low power consumption. Well, that's interesting. I didn't realize it was active. Anyway, cool.
Is it time for a trim, Kareem, or what?
I realize I set myself up for that. Like I've been shopping for Christmas or something.
Yeah. Anyway, okay.
Yeah, ear hair, nose hair, it just keeps on growing.
Yeah, and then let's see here. I had a little something that I wanted to show. I don't know if he showed up, so I don't know if this is. I'm going to share this. If this is boring to everybody, just let me know. it really aims at some of the little modules that you can buy now to power the little 5-volt modules. And one of the things that you have to watch, a couple of the things you have to watch out for. So in this case, if this is an ideal battery that actually puts out 5 volts, you can think of this as the cable or the connector that you're connecting to the 5 volts, and then this is your load. Well, if you're looking
7 in resistance, right?
right, yes,
Yeah.
and so the Raspberry Pi alarms at 4.7 volts. You know, you all, if you've been messing with Raspberry Pis for any length of time, and you've had this problem. So if you have a 5-volt supply and you look at 4.7, that means that you have to have a resistance of you have to be less than 0.06 ohms. All right. Now,
if it's drawing 5 amps.
huh?
If it's drawing 5 amps.
Right, if it's drawing 5 amps. And that's the spec, so I'm just using their spec. And the way a lot of the older supplies handled this, like the 4, in which we had a Raspberry 4, which didn't have a 5 amp spec, it had a 3 amp spec. But if you look at the way they handled it, was they bumped up the 5 volts to like 5.2. Okay. And that buys them a little more room for, I mean, you still have this internal resistance. And here's an example of a third party, the official Raspberry Pi 4 and a third party power supply and the impacts. So if you look at this line right here, you can see that the official Raspberry Pi 4, this is 4 now, not a 5. 5 is different. It's using gallium nitride semiconductors in it, but in different smart technology. But on this, you can see it's like 5.2 at
Open circuit.
load. Yeah, and you know, it just kind of like goes down, and you can see it's very linear, and that's the resistance. And so you can just take the slope of this line, and that tells you what the resistance is. And remember on that previous, we were talking about 0.6 and 0.1, and you can see that the official is actually 0.11. And the way what saves it is it's only going to 3 amps. All right. Now this other one is a third party one that I got purchased. And with its normal USB-C connector, you can see it made their spec, which was 4 amps, because this is a 4 and it's not a 5. 4 amps at but you can see how they did it. They bumped up the input voltage by 0.2 of a volt. If you took this guy and slid them down, they'd almost be on top of each other. So this was how some of these supplies. And this particular one, because it wanted to be able to use it with a Raspberry Pi 3.
They're not 16 inches on center.
Yeah, so they put on a
Well, that sucks. So you need 2 of them?
Alternative mini USB.
Is it designed into the thing where you're supposed to have 2 of them?
I think we need to mute Kareem.
Yeah, I think he sounds like he's talking about studs. Okay, so if you put a USB mini USB adapter on the end of the USB-C, so now you've got an adapter to the output, you can see how the impact of that was. Really negatively impacted by increasing that resistance.
So,
Now,
Doug, by adapter, do you mean just the electromechanical thing with no active components?
right. It was just a USB-C to a USB mini adapter that you plugged on the end of the USB plug.
Or micro?
Yeah. Okay.
Micro, I'm sorry. I said mini. It's my.
Because
Actually, it says mini, but I don't know. It's the one that goes in the 3.
Because I'm I'm trying to follow along and understand if you're talking about the interconnect from the power supply to the Raspberry Pi, or if you're talking about the internal design of the power supply and its effective internal. You're just talking interconnect.
Okay. Think of this as really, there's probably internal resistance to the power supply, but the one that's giving you this curve is most likely the cable. Otherwise, when you buy a Raspberry Pi power supply, it comes with a built-on cable.
The flying lead.
I mean, you can't unattach it.
Yeah, it's built in.
There. It's
Yeah,
built in.
Okay.
All right. So we're not talking about cables yet, other than the fact that in this unit, this power unit, yeah, right, with the cable, which you can't do anything about it, it adds to the internal resistance of the power supply. Okay. So you can't bypass it. So it impacts your output voltage.
So none of these, I haven't looked at them, but I'm inferring from what you say that none of these power supplies that you're talking about have something clever like a sense feedback from the final end of the wire.
The Fives do, Carl. Huh? When they went to the if you buy a Raspberry Pi 5 power supply, it does have, if you get those, that line will be pretty close to flat.
All right.
Okay. Depending on how well they matched it. Do you know what I'm saying? There's some process variation. So when otherwise they're boosting the voltage at the unit so that it comes out the end of the cable.
Yeah.
Right.
Yeah. A control loop inside the power supply should take care of that.
Right. Yeah.
Yeah.
And if you look at them, most of these are PD or what do they call quick charge 3 versions, and they almost always have gallium nitride semiconductors in it. Okay, so you'll see that as part of their pitch.
But that's just the newer generation, right? Because they switch faster and they give you smaller power supplies with less weighty magnetics.
Yes, but I'm just saying is, in this generation, in the Raspberry Pi 5, that's what you get.
Okay.
If you don't get that, you've bought a 4 that's been relabeled, and it's going to look like this. Okay.
Right.
So you don't want to do that, and you don't quite honest, what I'm done is I don't use any of my old Pi 4 power supplies anymore. I've just got enough Raspberry Pi 5 supplies and use them for everything. They're so much superior. Okay. But that's not where we're going with this. But I wanted you to see that this does affect the older Raspberry 4 power supplies. Because now we're going to talk a little bit about cables.
Can you go back to slide 1, because you've got, and explain what you mean, because you've got, oh, never mind. I saw the difference. Never mind. Carry on. Sorry.
Okay. All right. So this is from the USB-C spec. Okay. And the USB spec actually says, okay, so here's your little wall wart, if you want to talk about it. And this is your cable. So it's got a connector that goes in and a connector that goes out, and it has wire. All right. And they allow a 500 millivolt drop for the cable, for your cable. I'm just going to call a wire with 2 connectors, 1 on each end. It's a cable. Okay. Everybody with me on that?
Yeah.
And the ground wire is supposed to be able to handle double the current. Okay. So
half the voltage drop.
So it should, anyway, that's the spec. Okay. And what happens is when you buy cables, you might buy a perfectly in spec 30-inch cable. but your manufacturer says, well, hey, why don't you get the 6-foot one? Well, if they haven't sized the wire when they made the 6-foot cable, you're going to have problems. Okay. And so this is one of the things that you have to watch out for. So wouldn't it be nice to be able to evaluate the cables that you got? All right. Because I don't know about you, but everything I've got comes with a cable. And since it's an add-on, most of them are really, really cheap. You know what I'm saying? So let's, and here's another thing. So what are these? What is this 250 millivolts and 500 millivolts? What does it amount to? So it says 1.66 for the V-bus and 1.0833 for the maximum ground. All right, now let's think about that. What was the resistance on this? 0.09. So, you know, that one would be less than the 0.011. And this one here with the Mini was higher. So it's not surprising that they did what they did. Okay. Now, so here's where I was going to talk about, because I saw this on one of the pictures of a robot that was in Discord. Okay, so in Discord, and you see these modules for sale. They're about $6 to $8. Okay, if you look at them, they say 5 volts, 5 amps. If you look at them also, you'll see that this yellow wire is bigger than the other 3, and they work great. If you put a load tester on this, it'll be 5 amps, you'll have 5 volts. Okay, so these are pretty reasonably made. All right, now what happens is when they do this, because you know, if we're putting it into a Raspberry Pi, which is probably the reason we want a 5 amp supply, this just looks really convenient, doesn't it? And it's got a USB-C 3 plug-in. You just slap that sucker in there, and you're good to roll. Well, okay, because this has the resistance we've been talking about, it doesn't perform as well as these. Okay, the module's the same, but the cabling is different. And so you're going to see some of these are going to be really good, and some of them are not going to be so hot.
Yeah, I ran into a problem.
Yeah. So now the question you have to look at now, if you're only running 3 amps on these, they're fine. Okay. I'm talking about a person who's stressing it, but most people.
Doug, I've seen another thing with, I think it was one of those back when I did I put a Raspberry Pi 3B Plus on 2016 Club Robot.
Yeah.
And I think I used one of these to try and feed it. And if I recall correctly, there was, just as you say, there was a static voltage drop problem. But I seem to remember also that there is a transient response problem. So you know how these little single board microcomputers sometimes draw a quite big surge of current at the start, or they have very, very discontinuous current demands. So they'll go from a low level of current to all of a sudden they need a whole lot of current really quickly. And it, as I learned from back in the day at military electronics making stuff, the transient response of power supplies can vary tremendously. So some power supplies can keep up with those rapid current changes much better than other supplies. Okay. So I sometimes wonder if it's a double whammy with some of these cheaper modules, because they're little switchers, right? Yeah. And I wonder if it's not just the DC static drop, ohmic losses across the connectors in the wire, but I wonder if there's also transient response problems where the processor says, okay, I'm going to go from 1 amp demand to 4 amp demand, like in nanoseconds, and the power supply says,
I haven't got a drop out or a brown out.
Yeah. Yeah, I'm quite sure I've seen it. I think I even took oscilloscope traces of it. Yeah.
So anyway, I'm saying beware that there are gotchas with these guys.
Yeah.
And the other thing that you run into with them, okay, so your Raspberry Pi, if you're just chugging along with the Raspberry Pi, if you're pulling 2 amps, you're really hunking. You know what I mean? I mean, by itself, nobody here is running all 4 cores full out.
Well, not static, but I'm saying that there were, what I remember seeing was when we fired up the donkey car stuff.
Yeah.
I mean, there were periods of time when the processor would go from practically idle to practically flat out.
Yeah.
And I don't remember what those were, but it seemed to be enough that, or maybe it was that combined with the motors, and there was just enough transient demands that there were spikes that I did not expect on the power supply, and it caused processor alarms to trigger and reset.
Yeah, I'm thinking though that what a lot of people don't realize is every time you plug something into a USB port on a Raspberry Pi, you're usually taking a lot of current. You know, I'm just saying that's where, otherwise you might not, your Pi itself might be just idling. But if you've got a camera plugged into it, you got a LiDAR plugged into it, you're starting to pull some serious current out the USB ports. So something that you got to display, you know, I mean, just saying there's some things you have to watch out for. All right. So I'm just was saying, watch out for the, you know, I'm not saying you don't use these guys. I'm just saying, be aware.
Yeah.
Okay. Now this is 2 tools that I found actually really, really useful. This is a constant current load. I want to say it was less than $20, but I want to say it was even less than $15. This particular model is really handy to use. It's got a USB-C, it's got a bare wire connector, it's got an A plug and a micro plug. And so a lot of your things can be just hooked into it really, really nicely. And up here you can look at amp hours, you can look at current. There's a few other things, but mainly that. And it even has some of the older protocols for quick charge, but where you boost the voltage requirement. You tell the power supply, instead of 5, give me 7, give me 12, give me 15 volts. That's how they do quick charging. So it doesn't have the newest protocols, but the only disadvantage to this is that you got to have at least 3 volts. So testing a single cell like an 18650, you have to have a different solution. All right. And the other tool is this little booger. I just found out about this. These are like $2 to $3 on AliExpress. I don't know what they are on Amazon. And you see it's got 5 wires up there. I mean, 5 LEDs. And what this does, so you plug in, I believe, into this A port. Yeah, I guess you can plug into any of them, but I'm not sure. And then you put your cable from, say, here over to here. So, okay, excuse me. You use, I think it's a C port. So you have a C port, and you can, so like if you have a CC cable, you go from here over to here, somewhere where there's a C. I don't know where it is. If you've got an A going to a micro, you go to here. And so your cables are hooked, each end of the cable is hooked into this. And then when you power it up, it tells you whether or not you're using a data cable or a power only cable. So it's a quick way for you to quickly say, all right, hey, this one only got 2 wires in here. No wonder I can't communicate on this cable. It's not because it's dead, it's because it's a power cable. It's not a data transfer cable. And like I say, for $2, this is go ahead, slap order this sucker and let them ship it to you, you know. Now, but we'd like to really evaluate cables. We'd like to be able to say, well, is this a good cable or a bad cable? And you can do that by buying some I put non-JAM because what I mean is an older wall wart, USB wall wart, something that maybe a 15 watt wall wart or something like that. And then you can go ahead and use this module to actually generate this curve and find out the quality of your cable. So anyway, very useful. That's amazing how many times I've used it. There are some that are self-powered that are a little different but this guy is just so dang convenient that I would recommend this guy. There's a really inexpensive constant constant current loads that use resistors to set the current. They're probably less than $10, and they're great for doing 18650s and no single cells. I can share one when I get finished here. All right, so I was hoping he would be on, but he isn't.
I think you're talking about Bruce. Bruce is on.
Oh, Bruce, this kind of sums up why the disadvantages of this type of battery. These are very nice batteries. There's, for what they do, they're nice, but they're not really the best robotics battery. All right, and the problem for it is you can see there's two things going on here. The more current you have, the less amp hours that the battery can supply. So like if you're doing 0.45 amps on this is a 9 amp hour. A lot of them are 7, some of them are 8, but this is a big one. It's a 9 amp hour. And if you're doing a very small current, it gives you that 20 hours that they put on their listing. And it gives you 9 amp hours. But as soon as you start pulling current through it, like if you pull 5 amps, 5 amps is a half of a C. So it's about like this line right here. You can see that it's only going to last 60 minutes. And since it's 60 minutes and it only lasts an hour, that's really
a 5 amp hour battery.
Yeah, it's got a 5 amp hour battery instead of a 9 amp hour battery. And then if you actually go to 18 amps, which is 2C, that's this curve right here, you could see you'd be about 12 to 13 minutes and you only have an effective 3.6 amp hour battery. So, the RC style LiPo batteries, they beat it on weight. They beat it on current, being able to power large currents. The only disadvantage to them is you have to treat them with a little more respect. This guy, generally speaking, is very simple, but it's not really the best battery for this. Okay, so anyway.
That's great to know. So yeah, I'm going to have to switch batteries.
Yeah, I want to say that probably, I hope you have a UPS at home. If you do, your battery can slip right into that usually, and you gotta,
Yeah, I even have a spare UPS battery, and I pulled out the one you're showing, and then it's like, gosh, I wonder what that spare UPS battery is like. And I pulled it out, and it's like, gosh, this form factor is identical.
Yeah, they're the same. This is so I'm just saying, this is, I really, to be quite honest, I was glad that you brought up the problem. I knew there were some reasons why you didn't want to use these, but you really helped me to kind of look at it and see if why extra wide, not the best choice. Okay, so that I guess that was all I really wanted to show.
And
Huh?
And I used the previous slide, 2 previous slides also. I think I popped in when you were talking about that,
Okay.
the DC converters.
Okay. Yeah. Yeah. If you're using this one, that's, I mean, I'm not saying they're going to bite you in the ass. They probably won't, but you just do have to be aware of them. And the reason is because this nice convenience that they gave you just has more resistance.
Yep, that's what I'm running into.
Okay. So anyway, now I'll show you when I peel this, I'm going to show you, if you just some other alternatives real quick. So I'm stop sharing and I'm going to pull that. Okay. Can you guys see me? Yeah. Okay. All right. Give me just one quick second and I'll show another one.
Boy, we've got high quality presentations tonight with slides and everything.
That was a good one. I appreciate what Doug told us. I went through that exercise myself on all my USB cables several years ago and ended up throwing half of them in the garbage. They were so bad.
You get what you pay for, right?
I put a link in the chat to my blog where I documented a electronic load tester similar to the one that Doug's talking about that I built myself, for what it's worth. Use the second link. The first one, as Carl pointed out to me, is junk.
Okay, so one of the things I wanted to, so there's another one that looks like this that has some nice features. Now this is only a 3 amp one, but sometimes all you need is 3 amps. And these are very good. They have a little connector that helps you with the wiring, has a fuse line, inline fuse, very nice little module. If you're only going to use 2 amps or less, I really like these. These are Hobby Wing Ubex. I've never had these really go bad, and they can get as hot as a pistol, and a cheap pistol, and they will eventually turn themselves off. But I've never had one go bad. So
got to stop shooting those ghost guns.
Yeah. So I'm just saying it has an option of 5 volts or 6 volts. If you're just going to power a couple of servos, this is a nice option. 2 amps.
BEC, for those who don't know, means battery eliminator circuit.
Yeah. And then for, you guys who want honkers, there's this. This is a golf cart 5-volt power supply. Costs $10. It goes 10 amps. I've never actually used this in a robot, so I really can't tell you, but I have tested it up to like 5 or 6 amps, and I would believe 10 amps. So this is another kind of interesting option that you might like.
That's got a healthy looking heat
robot and works great.
Yeah. Those little modules like these and the ones that I was showing you before, they don't get very hot. They do pretty good. All right. So I guess that was all I wanted to show. Wanted to get that out of the way.
To kind of a continuation of what Doug was saying, this is an ESP32 board. It's the low-lin light, and it has a battery connector on it and a USB-C. You get them with the micros too, but this one is a USB-C version, and there is no 5-volt input except for the USB input, but you can run it on the battery, just a single lithium cell, and when you do that, you get rid of all the issues with one BEC, having to deal with, either high current demand or transient current demand because it's got its own power supply, its own battery, basically, or it's running off the battery. So that is kind of nice. I've never seen, you know, issues with the power supply with these because they do run on their basically their own isolated supply. So,
Ray, was that what you had on your robot? I remember when we did the interview, you had a little power supply.
yeah,
USB.
yeah, the outdoor one. The other thing, which is really kind of neat, or this is like a plug-in for USB, and it'll tell you what the output voltage and the output current is. So if you, I don't know, my outdoor robot, if I need to reprogram the ESP32, I can hook up to it and know, you know, well, anything that I hook up to, I can know what current I'm drawing. But the USB-C connector can also be used to charge the battery. There's a battery charging circuit on that processor. But it's just kind of nice to know, you know, if I'm powering other devices, you know, maybe through the 3.3 volts on the battery supply or something. It's just, I don't know, it's just nice to know that when you plug it in, you're not drawing unusually high currents or something and powering something else that you don't want to power up.
I find them so useful. I have one permanently stuck into my auxiliary bench 5-volt supply.
Yeah.
Because you always want to know that.
That's right. Yeah. Are you, you know, did you forget to disconnect something to program a processor or something? So it's just a lot easier.
Yep.
And the other thing, I don't know, I've been trying to get this to share. It's acting weird. Okay, entire screen. Let's see if it'll do this. Aha. Okay, now it's working. Anyway, this is the Random Nerd Tutorials website, and this is the article that covers, you know, using OpenCV, you know, the JavaScript version, and they're detecting this blue box here on, that's the mask image, and then they're actually looking, you know, it'll give you what the centroid X and Y values are of that blob, and it works okay. I mean, I think maybe one frame, a little or close to 1 frame per second, not much faster. So you could use it on a robot as a ultra cheap camera, but the update, you know, the frame rate is going to be very slow.
But you have to add the second processor to handle the OpenCV math. It's got to run in a browser somewhere. Right?
Yeah.
JavaScript version.
Yep.
That's what I was testing.
Say that again.
That's what I was testing. I showed you the screenshot from when I tested that myself.
Oh, okay. Yeah.
It works well. I liked it. It was easy.
Yep. Yeah, it's relatively easy to get working. And this is using Arduino, though. It's not using Expressive's tools. So it didn't seem, I don't know, the Expressive version didn't seem to work any faster, right? You still got like 1 frame per second or so.
Yeah, I've installed Microsoft's Visual Studio Code, and I've installed Platform IO extension on it, and I started to install the Expressive compiler in there, but have not succeeded yet. So I think the learning curve is going to be pretty big. Get to the point where I can attempt to use the Expressive tools to compile my TinyML stuff.
Yeah, and that article doesn't deal with any of that stuff.
No,
just,
he doesn't do any of that. It's hard.
Yeah.
He tends to look for quick hits because he and his wife make their living off what they do on that website. So they don't have a lot of time to experiment.
Yep. Anyway, so I've kind of experimented with that. But no, yeah, for $5, that's kind of neat that you can do that with, you know.
Well, cool, Doug. Thank you for a
That's right.
really nice presentation with a lot of data to back up a lot of guidance, particularly in the powering out Raspberry Pi's area. If you want to put links into some of those buck converters, I think that would be well appreciated, especially the one you had like a 3 amp with a few inline fuse and wires on the output side. I think that'd be real valuable.
Oh, okay, Paul.
Okay, next up in queue is me. So I want to report on a couple of things, but primarily my experiments and testing on RTK-GPS and how it's affected by USB 3. So at Robo Columbus, I found it necessary to move the antenna away from the electronics module. 3 feet away minimum really seemed to be what was required. And so that's why the antenna is sitting on top of this tripod on top of Mobot. Because if I didn't, GPS accuracy would degrade from 1.4 centimeters and get as bad as 2 meters. So I measured the accuracy loss by reading the HACC, horizontal accuracy field, in one of the UBX messages from the U-Block ZF9P RTK-GPS receiver. And it was important to root cause and fix this problem to enable the thing to be a reasonable mower with the used RTK-GPS to navigate with and to mow in a straight line. Because the antenna needs to be low on the mower. It's just not reasonable to have a mower with a tripod sticking up out of it that'll catch on every bush and whatnot that the mower goes under or by. And I had found an Intel white paper that described USB 3 as causing RFI issues. Particularly, they noted that it could reduce the range of wireless mouse radio comms distance to where the mouse wouldn't work as far away from the receiver if you had a USB 3 cable in the area. And they gave graphs that showed how it increased the noise floor across a wide spectrum. USB 3 has a 5 gigabit transfer rate, so its frequency rate is going to be its noise is going to be in the 5 gigahertz plus range, whereas USB 2 is 480 megabits a second, so it has a much lower frequency noise that it emits. So anyway, I conducted a test to determine whether it was USB 3 or something else that was causing the accuracy loss. And this is the configuration for doing the test. I had an RTK GPS receiver that was mounted in the Mobot electronics box. I connected its USB cable to my laptop so that I could power up the Raspberry Pi and down and swap its USB hubs, USB 3 for 2, while it was connected to the SSD, because that's really the highest data rate thing that I've got going on this thing. And then the antenna was on a long cable that I could move around to move it further away from Mobot or bring it closer. And so I made a video showing the testing that I did. And this is the video. And so initially I started with the electronics module, the Raspberry Pi, and its hub and the SSD powered off. Horizontal accuracy, this field in the bottom right, is being reported by the ZF9P as 1.4 centimeters. And so there's the antenna off to the side, and I bring it close just to show that there's nothing else in the electronics box that causes a problem.
And you weren't wearing a tinfoil coat or anything, right?
No, and it wasn't me obstructing the radio signals. So then I turn the Raspberry Pi on, and it starts booting off of SSD. But the antenna far away, it's still 1.4 centimeters. And then I bring it closer. I wave it around to show that it actually is tracking movements of the antenna and still maintaining good accuracy. But then once I bring it close to the electronics box, horizontal accuracy grades significantly, and all of a sudden jumps up to 100 centimeters plus.
Over a meter, yeah.
I move it away, and then we see the sort of homing behavior that you see on horizontal accuracy as RTK is trying to get back into RTK fixed mode. And it sort of like winds itself down, and then a few seconds later, it will just jump. So now I turned off the Raspberry Pi and switched the hub over to USB 2 hub, and waited for it to jump back down to 1.4 centimeters, indicating it had RTK fix, which it did a few seconds later.
So are there USB 3 cables off of both hubs as well,
So,
or no?
let me just finish, Ray. So with the USB 2 hub, I'm waving the antenna around right over the top of the electronics, and so the hub is still active. The USB 3 hub is still powered, but the I'm sorry, I got something wrong there. Let me just go back. I still had the USB 3 hub in there, but it had regained RTK, and I didn't bring the antenna. The Raspberry Pi didn't boot. It failed to boot. It was connected, but it failed to boot. So the USB 3 wasn't emitting the kind of radiation that it did during boot. And then I swapped out the hub and put a USB 2 hub in. So now I can move the antenna right over the top of the module with the Raspberry Pi booted. So this is the next day, this third segment. And I can move the antenna right over the top of power module, and horizontal accuracy stays in the sort of 1.5 to 2 centimeter range. And move the antenna all around the electronics. You can even sit it on top of the electronics module, which is what I need for the robot mower. So, so what I've concluded is that, by the way, I wasn't watching my screen. Did that video show?
Yeah, we could see the horizontal accuracy.
Okay, great. So I concluded that USB 3 RF interference is the cause of Mobot's RTK-GPS accuracy degradation, and that replacing the USB 3 hub with a USB 2 hub makes the problem go away. But then that begs the question, what other consequences might there be? For example, slower disk access, since the SSD is hung off of a USB 2 hub now, operating at 480 megabits per second instead of 5 gigabits per second. So I did some testing of that and found that the reboot time from when I requested a pseudo power reboot until I could log in with a new SSH session and get a shell. With the USB 3 hub, it was 55 seconds. With the USB 2 hub, it was 1 minute 31. So about a 50% degradation, a 30% degradation in boot time. However, the Mobot software launch time did not change, stayed at 23 seconds. So my conclusion is that disk performance was degraded by the USB 2 hub, but not enough that I care about it, because I care much more about getting the antenna low on the robot. So the most important takeaway is that USB 2 doesn't interfere with RTK-GPS, whereas USB 3 does, and the disk performance was degraded by the USB 2 hub, but not enough that I care about it. And so hopefully this is the solution. Got a little just arrived today, a little Belkin 4-port USB 2 hub, cost about $16. And I haven't tested it yet. I was using a different USB 2 hub, but I'm pretty confident that this one will work the same. And finally, at the end of every slide deck, you have to have an obligatory slide with a bridge. So there you go. That's my attempt to live up to Tom's high standards for presentations.
Well, an outstanding accomplishment, Paul. Thank you.
Thank you.
Very nicely done.
I'm wondering if the USB 3 hub is not shielded, and maybe the 2 is.
It's a good question, Ray, and I don't know the answer. The Intel article was kind of generic. It didn't describe specifically about particular hubs, or it just said USB 3 to devices. I would think that the cables for a USB 3 cable would be shielded, because they shield gig E cables and 10 gig E cables. I would think that, and USB 3 is up in that frequency range.
Right.
So it's certainly possible that the USB 3 hub shielding is a problem, but I'm afraid I don't feel like I have time to try and understand. Well, I can spell RF, but that's about the extent of it. And it's not my goal to really diagnose how one might improve shielding to avoid the situation. I think it's information worth sharing with the group that
Right.
USB 2 does a whole lot better. USB 3 really sucks for interfering with RTK GPS.
One
So
thing,
you already had a USB 2 hub though, right? Why did you get another one?
Because I used the other one on my desk. I just borrowed it from my
okay.
desk.
Yeah.
Paul, you could USB 3 cables. They have that little blue thing on the end of it.
Right.
If they have an A, because there's two
Right.
versions of those. If you're using the ones that are white, they're not shielded. If they're blue, they're supposed to be shielded.
No, I had the blue ones.
Okay.
Yep, this was blue from Raspberry Pi 4 to the USB 3 hub, and then blue from USB 3 hub. Well, the hub to SSD adapter had a blue USB cable on the end of it, and it was a powered hub because you don't want to run an SSD off of Raspberry Pi power.
Mm-hmm.
Could it be that the buses were running at different bandwidths? I mean, isn't USB-C, doesn't it have a higher top end bandwidth? So might it have faster switching rates on the digital transitions?
It's USB 3 versus USB C. They're different things, right?
Well,
USB C is a connector format. USB 3 is a signaling format.
So 3 versus 2. So, well, but the same thing, right? So what are the max speeds of USB 3 versus USB 2?
USB 3 is 5 gigabits per second. USB 2 is 480 megabits per second.
So it's almost a 10x difference in.
Yes.
Okay,
Yes.
so that's got to. I'll be willing to bet that's got to come with a comparable difference in rise time on the digital transitions.
Yes, exactly.
Which means that USB 3 signals will have more broadband noise.
Exactly. And this paper, it's kind of lengthy, 22 pages, but it's really a good read. And they go into the USB 3 and the impact of USB 3 noise on interoperability and to wireless device performance and mitigation methods, including shielding the peripheral device, improving shielding on the notebook, connector, and wireless antenna placement as ways of ameliorating the RFI issue. But broadly speaking, it's exactly what you say. 10x the transfer bandwidth equates to much higher frequency EMI, and it turns out that actually is demonstrably detrimental to RTK-GPS.
Yeah, I believe it.
I wonder what the frequencies of the L1 and L2 band are in RTK. I want to say it's like 1.75. Is it mega?
I thought
No,
they're in the
it can't be
1.5
gigahertz.
gigahertz range, but
Yeah.
That would be that's like just like a 5 gigahertz signal is going to like mess with that stuff.
Yeah, usually what messes with it is not like the first harmonic, but maybe the second or third or fourth, if it's like an exact multiple or close to a multiple of it.
Sure.
It's kind of like you get, peaks from those kinds of transmissions. And
yeah, if I remember correctly, they gave, so here's a sync function of USB data rate. So it's the USB data is scrambled and it spread spectrum on the clock.
Right.
So here you have, I mean, to your point, Ray, you've got a dip at 5 gigahertz, but you've got a lot of noise coming out well below 5 gigahertz, as well as up to the second harmonic.
Right. Yeah.
And so here's the measured USB data spectrum. They say it's very broadband from DC to 5 gigahertz. And so dBm, I don't know what dBm per 100K hertz is, but you're going up to minus 50 dBm, really from DC up through 3 or 4 gigahertz. So that's putting out a bunch of RFI right in the in that 1.5 gigahertz GPS band.
Yep.
So then they go into emissions from the cable, from the device, and so it's a really good paper and worth a read. And I feel like I demonstrated adequately that USB 3 did massively degrade RTK-GPS to the point that it was inoperable, and that was not the case with USB 2.
Okay, so Paul, going way back, did I hear you correctly? Do not power an SSD with a power off of a Pi?
Yes, that's a recommendation because they can draw an amp, and the Pi 4 at any. Okay, so I'm really talking about the Pi 4. I know you're using a Pi 5, and I can't speak to its ability to supply power, but the Pi 4 is just marginal on the 3 amp power supply being able to power it sufficiently, and they recommend that if you have high power draw devices like an SSD or a smart camera, that you run them off of a powered hub.
Okay, I'm going to have to take a look at that. So I haven't noticed any problems on my Pi 5. The SSD is just so much faster than the micro SD.
Yeah, I have no experience with Pi 5s. I'm just talking about what's recommended for Pi 4s.
That's interesting. I wonder if you I'm not certain what the composition of mu metal is anymore, but I wonder if you could find a mu metal plate and stick it between your GPS antenna and the box and see if that would shield it.
Yeah, I don't know, Ray, but and it is certainly a worry that USB 2 devices are getting rare these days. Almost everything's USB 3.
Oh yeah, USB 3.
And I had to search moderately hard on Amazon to find a USB 2 hub, powered hub. But yeah, that's a concern for sure.
Yeah.
And so my goal is the fastest time to a solution.
That's right. Amazon.
Yeah. If I can buy it and it solves the problem, then I'm going to move on.
And move on. Yeah.
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 So
hey, Doug, do you remember what mu metal shields are made out of? Is it like a layered, or Carl, maybe you remember? I don't know if Carl's.
Yeah, my internet just totally cratered. I had to come back on by my phone here, so I'd missed the last 3 minutes, 4 minutes.
Oh, I was just wondering, do you know what mu metal shields are made out of? Is it like a layered
mu metal?
Or is it just no?
No,
I think it's a material.
Yeah, usually it's something that it catches I think it's made for more the
Yeah.
magnetic waves, not electric waves. That's why it usually has like, made out of something steel. But they're also, I thought they were also plated with other materials.
So I have one other update. If there's no more discussion on USB 3 and RTK-GPS, I was very excited to finish about a week ago, finish the build of Trekbot, which is a Traxxas TRX kit. I've managed to drag it out from October until now, but sadly I finally finished building it, and it was a real lot of fun to build. All metal gears, and you assemble differentials and gearboxes and all kinds of stuff. So at the moment, this is going to be my new robot platform. At the moment, it's just an RC control platform. But I hope that this video is going to play. I believe they can have curbs in Robo Magellan, and it.
I am amazed.
Isn't that cool?
Yeah, not bad, huh?
That's pretty cool.
Isn't that
Got to
cool?
hit it at an angle, huh?
And so this is Trekbot. He's a 10th scale crawler with he's got a DC motor that I'm going to replace with a brushless DC, and then a battery in there. RC receiver. It's got 2 servos on this side, which are differential locking servos. They operate cables there they are. Cables that go down to the differentials and lock the differentials or unlock them. And it's a pretty neat kit. It's got like suspension and anyway, you guys have probably seen these things, but I was pretty excited to finish it. So anyway, that was my other update.
Oh, good. Thank you.
Hey, Paul, before we get out of here, next week is the 24th, and the next week after that is 31st. I'm assuming we're not going to have meetings on the 24th and the 31st. So
Everyone in favor, thumbs down.
so what I'm saying is, if people have things they want to talk about, should talk about on Discord.
Yeah.
Discord should be our holiday communication path.
Good point. Thanks, Doug. And I'll send a message out to the list saying, hey, we're canceling RBNV for the 24th and the 31st.
Yeah.
Okay.
Okay, that's all I had, and that was the end of the queue. So unless someone's got something else, let's throw it open for open mic.
Okay, I'll ask about Discord. Is Discord live chat, or I mean, is it like,
Yeah.
or is it more like it is? It's not like a forum. How's
Let
it
me
different?
show you.
It's kind of a mix, Mike.
Yeah.
Otherwise, if the guy you're writing is on Discord at the same time as you are, then it can be like a live chat.
Okay.
But if he's not on, it just leaves, it's more like a forum then, and you respond to the message. So like when you go on to Discord, it'll say there are 4 unread messages or something. And then you just go to them and look at them And if they something that's your concern, then you can respond to them. And the guy doesn't have to be there, but if he or she is there, then they can respond immediately. And that sometimes happens.
Yeah.
I've caught.
And there's a fair bit of good technical discussion that goes on in these various categories. So the different threads of conversation, like I posted that EMI stuff, and there were various comments about it, like from Mark and Kareem, and so you have there's a whole. It's more like chat, really, like chat on SMS, except it's divided into categories, and it's just the people who are on the server and choose to read it at any given time. So there's stuff on AI, and I mean, it's really a pretty neat platform for, and a lot of the technical discussion outside of this meeting takes place there.
And the chats hang around with hyperlinks and images, and you can search through the stuff and go back later on. So it's pretty convenient.
So does the Robot Club have its own channel, or is there?
What I'm showing here is the DPRG channel, and we've got all these. They call it a server. The DPRG server is what they call it.
You're not presenting, Paul.
What?
You're not presenting anything.
Sorry.
That's okay.
Was I not presenting before when I was talking about it?
No, you weren't.
No,
you weren't.
Oh, sorry. Sorry about that, Michael. What I was trying to show was a list of topics here, like general and most active, things like code, controllers, sensors, ROS, AI, navigation. And so you can post in any of these, and your conversation with whoever wants to pitch in. It's a lot like SMS. If they're live, you can chat back and forth pretty much real time. If they're not, then you just post and they'll post back. And everyone, you end up with a highlight on the channels that have new messages.
Okay, cool.
It's funny. I was looking at that video by Spies.
What's the Robot Club's channel, or whatever you call it?
This is it. I'm showing.
I posted a link.
Okay.
There's a link in the chat.
Okay.
Yeah, I can repost it if to make it more convenient, if you would want to just mouse over it. And for anyone who doesn't know, if you want to make an invitation to someone to join the server, you go to introductions, click this people plus icon, and it will give you a link, and then you just copy that, and then you can go over and paste it into a chat or email it or whatever to get it out to people.
Okay, cool.
Yeah, it's really a good tool. Recommend it.
Thank you very much.
Yeah.
I'm
Okay. Open mic. Who's got something?
I got another question. I remember, I think y'all discussed a few weeks ago about blob detection is getting obsolete, so what are y'all going to start using now for that? What's the alternative? If I heard that right.
AI cone detection. So.
Yeah, I think a lot of people are experimenting with AIs to recognize cones more specifically versus just looking for orange blobs.
Okay.
Yeah.
Or any shape, whatever shape that y'all pick, right?
You program it with AI, or we just show it a lot of pictures of it, and it starts figuring it out.
Yeah.
Yep.
A YOLO model may know off, if pardon the phrase, off the top of its head if it's a construction zone. That wouldn't surprise me in the least bit. YOLO knows lots of various objects. And it wouldn't surprise me if it already knows what a construction zone is.
Yeah, actually, YOLO 5 does not. I thought it would have a cone in it, but there's no cones in it. I guess Doug was primary, or the person that started it first. He has like a collection of photos or data set or whatever you want to call it for cones. It's over 300 pictures, Doug?
Yeah, something like that.
Yeah. And you have examples of cones and not cones, right? Just background images.
You have to have a percentage of non-cones, yes.
Right. So
and, I'm been thinking about it, and there's a few pictures I want to cull out of it that I think might confuse the model a little bit. So but I'm not going to do it until I get some more pictures put in.
Mm-hmm.
So,
yeah. So I don't know, Doug.
It's very blurry when you're taking the pictures.
So do you need like a Raspberry Pi with an operating system to run the AI?
There are appliances like the camera I'm using has all the goodies in the camera.
Yeah.
So yeah, it hooks into a Raspberry Pi, but the Raspberry Pi isn't doing hardly anything. It's all in the camera.
What you're showing, Ray?
Okay, this is a Max Cam, and you can take the individual images with this. You download them to Max Hub, I think it's called.
Yeah.
And you can create a model on it and then load the model back onto this, and you can use it to basically detect cones. And it's
pretty cool.
Probably the cheapest and lowest power setup that I've found to do that. I don't know of any that are cheaper or consume, a fraction of the power, like,
Yeah.
You don't.
It's so there's a Huffy lens, but this is so much better than a Huffy lens.
Yeah.
There's also a hi-hat.
It has a touch screen, LCD touch screen on the back that shows you what the camera's seeing. It's pretty much the code that you use to operate it is loaded on an SD card, and it has this little wire sticking out of the bottom. You can barely see it, but that has, you can actually have a Wi-Fi connection to, I forget what their GUI is called. But, you can easily connect between this and your laptop and see what it's seeing, make changes in the code. And this, it's not just like an AI camera. You can do OpenCV kinds of things. Like you can do blob detection on this very easily. So I don't know, it's the cheapest one over the, Black Friday. I actually bought 2 more of these. So, and they actually have a later version out now. The packaging is a little slicker, but it went up in price a little bit. I think you can get them, the older version for around $50. I think now the newer version is like $60, but still you look at, all the other setups, they're going to be a lot more expensive. An OpenMV camera to do the same thing is probably going to be about $120. I really haven't priced the other ones. I've been kind of focusing on that, but
I think it'd be real. Nobody's really tackled it because I guess people are waiting. But you know, Raspberry Pi now has a couple of AI solutions. One where they're using a Sony camera, and then there's some where they're using an accelerator that sits in the M2 slot. So I don't know yet. And I think they now have a new one that uses, you know, a hat. So it's using the same slot, but it's different from the first one. And I've heard they've got one that goes out at 13 what is it, T-flops or whatever they call them? Huh?
I believe that is one is tops.
Tops, and then the other one goes at 26, which, you know, it's more expensive, but it's not double. So
is that the Halo 8?
Huh?
Is that the Halo 8? However you say that. I think I have that.
Okay, I don't know. There, like I say, there's one that you plug in into the hat. That one's the first one that came out. It's a third-party accelerator that you plug into an M2 top. But then they came out with one where it's the chip is literally, you know, soldered to the hat. And I haven't seen any. I really haven't got the details on it. But apparently when they did that, they also made an option where you can double the speed. A lot of cool stuff, but it's not, I don't think it's shaken out yet. I think you could, you know, spend your money and be regretful next week.
I've never done that before.
Yeah.
I have a few products that I may send back, and I am debating whether or not to bite the bullet and go with the NVIDIA board. So I just found out that they have the GPIO pins, and you know, the camera I plan on using, I believe, is compatible with that. I want to do some AI. We'll see. Do I have enough power on the Pi 5 to do navigation with the RTK, which I think the answer is yes. So, but I have to figure out what I'm going to do.
You know, like I say, right now we are blessed with a lot of cool toys.
New stuff.
More toys than we can absorb. So you just kind of say, well, I'm going to do this, and then when you actually kick, I think somebody put a video on the Discord where it said, I'm going to complete this project, you know, or think it was part of the video. And I'm thinking that we might need to get to that point right now, because you can chase this stuff all the time.
Oh yeah.
Yeah, that's one of the things. I think this guy consumes like 160 milliamps, where a Raspberry Pi 5 is what, up to 3 amps now or something.
Yeah.
So
Up to 5.
Well,
yeah.
that's fully loaded, but yeah.
Yeah.
What, Ray, what brand is that? What is that?
It's a Max Cam.
Max Cam.
Yeah, there's the box.
On a minute.
MAIXCAM.
Okay. Yeah. All right.
You can get
Anyway, it's relatively, I think it's the easiest one that I've found to use so far. So
Is it
it
a
seems
Pro?
like, what's that?
Is it Max Cam Pro?
No, the Pro's the new one.
Oh.
I have the previous version. I think the Pro is like $60 now, or somewhere around there on AliExpress, and these you could get them for like just under $50.
$48. Amazon.
Oh, okay.
Tops NPU. I think I got it.
If it's called the Max Cam Pro, that's probably the one.
Yeah, this is called no, this is the Max this is the SI
Slipede.
Speed Max Cam.
Yeah.
Well,
I think
anyway,
the Pro is also made by the same group, but it's just got slicker packaging, and
they take more.
I think the LCD is bigger on it.
Oh,
Say
here's
that
a
again.
Pro right here for $64. So I'm looking on Amazon.
Oh, okay.
Yeah. Okay. Thank you.
Sure. So I think there's been at least 3 of us that have played around with it. Doug, Pat, and I. Are you guys planning, Doug or Pat, are you planning on using it on one of your platforms, or?
I'm planning on using it on the Cone, the Robo Columbus platform.
Okay.
Yeah. My thought on it is I'm going to try and field more than one platform this year. And because of that, but the first one is going to be using this Pi Insight, which is essentially an OD light without the depth camera. Okay. And the reason for that is because I've already had the programs for it, and it's just simple. But I'm going to be using that to start off with, and then probably go to, I want to use the MaxiCam because I think it'd be fun, you know. It's just like the what is it, the Max A10 or 101, you know, got
the
LiDAR thing.
Distance,
It's an
camera.
It's that one would be fun to play with too.
Yep.
So
yeah, there's another example of a device that, you know, what you get 100 by 100 depth, you know, pixel depth map, and it's consuming around 100 milliamps too. So they're, you know, I don't know, they're just power wise very efficient for what they do. So that's why I don't like the Raspberry Pis. They're power hogs. So
Let me see if I can present this window. How come it won't let me? It won't do it.
yeah, when I tried to present earlier, it wouldn't let me. I had to get out of the meeting and get back in. So I don't know if there's something weird going on. It let me do it afterwards, but.
hey, Paul, did you make your pitch for the dinner on the 30th?
No. Let me do that. So not dinner, for lunch. For anyone in the DFW area, we're going to have a robot power lunch. They used to do this back in the 80s and 90s, apparently, and we're going to revive it in place of the December meeting, and it'll be on Monday, the 30th, and it'll be at Kelly's Craft Tavern, which is on Preston Road, just north of 121, Highway 121. And it's going to start at 11. We'll have a private room, and we'll be able to socialize for an hour. We'll plan on eating lunch around noon. So we'll have servers to take our orders, and we'll be able to get drinks and food, and probably wind it up around 1 or a bit after, but that will be in place of the monthly December monthly meeting. So don't come to the Makerspace, anyone who's watching. There is if you look on the DPRG mail list, DPRG list at groups.google.com or googlegroups.com, there's a form that you can RSVP. I'd love it if people RSVP. We've got about 9 RSVPs at the moment, hoping for maybe a dozen folks to show up and just enjoy, meeting actually in physical person, having a beverage of your choice and lunch and conversation about robots.
You should point out that the club isn't footing the bill.
Yeah, so what
BYOB.
I've published is that the club that everyone's responsible for their own food and bar tab. As Steve suggested that, hey, the club pays for pizza at a monthly meeting, so maybe it ought to put hors d'oeuvres on the list. So that hasn't been decided yet. That's I'll run that by the board and see what kind of feedback I get. But I thought that sounded like a decent idea. But yeah, basically your own lunch and drinks and bar tab.
Cool.
I came across. I went and saw the Wild Robot movie today. It was kind of lame, to be honest. It was typical Hollywood. What's their animation, DreamWorks stuff. But what was interesting was the robot's name was Roz, and I thought that's got to be an homage to Roz, the robot operating system.
I believe it is.
So that was pretty cool. Let's see if nobody else has anything at the moment. I came across a really interesting set of videos on SLAM during the week that I can share.
Yeah, I saw Subservience with Megan Fox on Netflix, but it was okay for a Netflix subscription. I don't know if I'd see it in a theater or not.
Okay. So usually SLAM is done with LiDAR, and it usually involves making a LiDAR map and driving a robot around in a loop around some field that you want to map. The goal being to create a map, and it comes back to its starting location, and once it recognizes it's at its starting location, then it works both forwards and backwards around the recorded map and kind of like figures out what errors there were in the distances and angles of things as it explored the space. And like I said, that's usually done with ranging LiDAR. And what I came across was this thing called real-time appearance-based map, which is a SLAM package that instead of using LiDAR for ranging, it uses any kind of I won't say any kind of, but several kinds of RGBD sensors, so red, green, blue depth sensors, and it uses the depth data from the camera. So this could be a stereo camera or a Kinect, where it's structured light camera, or some other kind of RGB and depth camera, and it uses features in the video to identify the points whose range is computed. So see, I'm just going to bring this up here.
Yeah, I think the SLAM is, you can use multiple types of input for the SLAM. Now, an interesting thing I recently found out is that the makers of RP LiDAR are also the makers of SLAM.
So anyway, this is showing in the left upper the color image. I think the left lower is the depth image, and then on the right is what it's computing as the map that it's building. And at the end of this, they process it. So they run in a loop. They walk in a loop around this corridor, and at the end of it, they have a 3D model of the building. So there's the 3D model that came out of this SLAM mapping exercise, and there are numerous other demo videos, including one that I thought was particularly interesting, Outdoor Stereo SLAM, where they okay, so the left is the RGB image, and right is the map that it's building as it goes, using the depth information and merging that with the RGB information. And they go through some trees, and this is actually a robot. So you can see this is being done with ROS, so you can see the robot joints rotating as the wheels move. And just in the interest of time, I'm going to speed this up and go forward. So they go walk among the trees, and it finds the trees. But what's most interesting is when they get to the 3D model of the ground. And this pertains to what Doug said or suggested as an advanced challenge for RoboColumbus to use data collected on previous runs during subsequent runs. And he was really thinking about something like this, where you have, or at least this could be one possible implementation, where you make a map as you go on run one, and then you use it to navigate perhaps more quickly or more accurately on subsequent runs. And I think we get a view of the as-built map down the end here, if I remember right. But I thought it was really neat to use points in an RGB image and their depths as reported by the camera in a SLAM algorithm to create a map that has, if you will, visually recognizable features in it. So there's the map that it made, and you can like look at it, zoom into it, pan around it. It's pretty neat. So anyway, that was I thought that was really neat.
I was looking at that RTAB map and that video and a paper that they wrote about it a few months back, and it definitely looks interesting. I haven't had a chance to try it myself yet, but was planning to do that with the RealSense camera.
If you do, Kareem, I'd love to hear, because I'd like to try it too. It just seems like really neat tech.
Yeah, I don't know if I got enough horsepower on my buggy for that, but we'll find out.
Yeah, I
So
believe
is-
I'm headed towards one of those RealSense cameras also.
It looks like you'd have to export the depth map, so you'd get some significant data transfer rates between the camera and the Pi or whatever's receiving. It could be a laptop, and for creating the map. And
Yeah, I
and
imagine
Bruce,
it's pretty high data rate, but I haven't really messed with it yet.
So in that, you're saying the actual colors that it saw of objects were incorporated versus just a white dot to indicate a depth or a wall or.
It's 4 panels.
The RealSense camera has a 1 color sensor and 2 depth sensors.
Okay.
And it can integrate them. It can provide you with sort of a composite of the depth map with the with just the color camera, and you can use that to color your pixels if you're not using.
Okay. Yeah.
If you're not using the depth data to color them.
Right. Okay. Yeah.
but my understanding from looking at some of those features is that whereas conventional LiDAR-based SLAM looks at the distance to walls and corners, this uses appearance. So it uses the fact that it sees something that looks like a door or a feature of a door, like a corner of it, or
no, when they talk about features in a depth camera, those are things that are very abstract. So they're not like what a human would recognize as features, but really repeatable corner detections and things like that. As an example, in the gradient. So it's just things that give the two difference cameras, the depth cameras, something to difference on, but from a like optical algorithm point of view, not really from a higher order object recognition point of view.
Okay.
But what it does is you can extract you can extract a point cloud, or you can just buy or you can just get the depth of every single pixel coming from the depth cameras, and then you can find the corresponding pixel in the color camera if you want to overlay them.
And if you're doing this inside, you need the IR version, because otherwise it has difficulties calculating the depth for corners of walls that are painted the same.
And some depth cameras have active projection, usually of an IR pattern, and that's how the RealSense cameras do it. So that's also detected by the algorithm and helps with, especially in like low feature environments, like if you have a solid plain color floor, painted gray or something like that, that can be really hard to pick up without some sort of grid or dot pattern projected onto the surface.
Yeah.
But that doesn't work terribly well outside because at least not in the daylight. It gets swamped by daylight. But usually outside, there's much more surface roughness in the surfaces that you're on. So you're going to get that as visual roughness too. But most of the work is being done by the depth camera. But there's still a fair amount to sort of construct the map itself. So our tab map seems like the most active of the ROS2 projects out there that generate maps from depth cameras. So looks promising.
Well, you're always on top of whatever I bring up, Kareem. Hats off to you, sir.
Always studying.
Good on you.
It's the Utes. It's keeping him active, you know.
It's the youths.
That's right.
And Intel has videos on their various RealSense cameras and how they work. So
I'm using the D455, and I'm finding it pretty nice.
awesome.
It has an integrated IMU as well. It's a Bosch. It's a B&O. It's not the 55, so it doesn't actually have integrated fusion of the sensors. So you're just looking at and it has only 6 degrees of freedom. But they're still high quality sensors. But you're looking at the gyros and the accelerometers independently. And I have it mounted on my. I was gonna present, but I can't because basically something crashed on my robot, and I've been trying to get it up since that happened. It was working at the beginning of the meeting, but I can show. Can I show?
Which model are you using?
The D455. Nope, can't do that. Oh, I have it open somewhere else. Well, let me select my other camera. There it is. Yeah, so there's my robot. It's kind of hard to see, but the D455 is mounted on the on the arm right in the front, so there's a wrist there, so I can sort of bend that arm down and forward. This is what I was going to show, but the demo isn't working right now, so I'll have to do that after we get back over the holidays. But it's mounted right on the top of that stalk, if you like, in the front, and then that triangular shaped thing and the mast above it, which you can't see the top of, is the GPS receiver.
I just
but
bought the
I'll
camera, not by your description, but because I know what it looks like.
yeah, it was a little far away in that photo, I guess. But that's where I'm, the reason that the IMU is helpful is because that arm does move, and it can help me find sort of the attitude of the camera while the arm is moving relative to the base.
I did a little bit of work, and Bruce, you were asking about Docker, and I did a little bit of work and updated my ROS2 Docker to run Jazzy, and tested it on my laptop, and it would run some of my software, but Jazzy was missing a couple of the packages that I use on the robot. So I haven't updated the RPi ROS2 Docker yet.
You haven't updated what?
the Docker that runs on the Raspberry Pi. I updated the one that runs on my laptop, and was able to run the scripted bot mover that drives a robot around based on a script in Jazzy. I haven't built the Jazzy version of what would run on the Raspberry Pi because I seem to be missing a couple of packages.
Yeah, but you do have it running on your laptop.
Yeah.
Yeah, so there should be a way to get that Docker image from your laptop to your robot.
Yeah, I run a different configuration, a different Docker configuration on the robot than on the laptop for a couple of reasons. Obviously, you have a different instruction set, so you build off of a different base. But then there are things that the robot has, like a real GPS sensor, and the need to convert between Latlon and UTM, which necessitates certain packages that you don't need on the laptop, and blah blah blah, on and on. So that's what they are actually different. I do actually run different packages, but I don't know if you looked at the tutorial and the associated repos that I posted on Discord, but it's all in there. Should be able to copy it, follow the instructions. If you can't, drop me an email or a Discord note or something.
I think you made a point and I missed it. About me contacting you, or?
Well, I was just saying, well, let me ask you first. You posted about wanting to run a ROS Docker with using Jazzy. Did you see my reply on the Discord?
Yes.
Okay, so I replied with a link to my webpage that has a tutorial on how to build and run the Docker environment, if you will, that I use, and build a container which has a bunch of customization in it, like editors and this and that you really want. And so I was just saying that's what I've got running Jazzy on a laptop now, and you should be able to follow the instructions and clone the repo if you should want to. Or maybe you're far enough ahead that you don't need to do that. But if you have run into any problems with what I've done, welcome to contact me.
Great, thank you. Yeah, so today I went back through, and it's actually from Kev's Robots, and did the Docker with the RP LiDAR and got that operational again. So my notes keep getting better and better. So his note, I don't know if those are just files or what, but they have some errors in it, and I have documentation with all the corrections in it. So, but that was ROS to Humble, not Jazzy. But I'm just going to take it. So it's Docker. You can run it. You can run Humble in one. You can run something else in another. And so I have the RP LiDAR working, and then I want to get a Compass publishing, and apparently the Synth Hat works with up through RPi 4, but not 5. It can have problems with 5. And I switched to a DF robot compass, but that's geared towards the Arduino and not the Pi. And so I took an Adafruit code for their compass, and then I made one minor tweak to it where I switched Y and Z. And I was testing that earlier during the meeting, and yeah, that works just fine. Just a minor tweak, I was able to use the Adafruit driver for a compass, similar compass, but they are different. Apparently, there's something about the Y and Z axes.
Yeah.
But I hope to get that one running in Jazzy.
Yeah. And I want to move to Jazzy because Jazzy supports a new non-DDS communications protocol that they call Kino, I believe is its name, and it doesn't have the pitfalls that DDS has. So anyway, I'm looking to try and migrate to Jazzy, but the issue is, as expected, not everyone has ported all of their packages to Jazzy yet, so there are some discrepancies.
Right. So yeah, it looks like a lot of things are not ready for Jazzy. Bleeding edge.
Yeah.
Hey, Kareem, there are no more of that robot base on GovDeals, right? They're been gone for a while. Isn't that correct? Kareem?
Kareem's still on.
Sorry, no, I haven't looked since then, so I have no idea.
Oh, okay. Oh, I thought it was a one-time deal or something.
It was a particular government auction. Apparently, they were Air Force property, and which I got just by seeing the boot up parameters on it, and it had some sort of Air Force, I don't know, item number associated with it. But yeah, I haven't looked for that. I haven't looked for any P3 ATs since then.
Yeah, I just did. I didn't see anything. It looked like it.
They were all over the place back in the day. I mean, they're pretty popular. There have been there's still some colleges using them as training robots. There was an Australian college project 2 summers ago, I think. Haven't looked for it since, but they were asking them to run RAWs. As far as I know, I'm the only one who has ported it to RAWs 2. And the groups have sort of gone kind of silent. There used to be a support group around it, but they've all gone silent. So yeah, it's been a while, probably 10 years since they were the cat's meow. That's a long time in robot worlds.
Ooh.
Well, are we losing energy? Time to call it a night, perhaps?
Sure.
I'm waiting for my internet to come back.
Hey. Oh, welcome back. I was just seeing. I was doing last call for any further discussion on open mic.
I've been listening in, nothing here.
All right.
But
All
I'd like to
right,
wish
well-
everybody a happy Christmas.
Yeah, everyone have a happy Christmas, and see some of you at the luncheon on the 30th.
In Oklahoma, pretty far north. I'll be there. I think I'll be there. Yeah.
Come on, it's Baja, Oklahoma. It's not full blown Oklahoma.
Merry Christmas, guys. Happy New Year's.
Good night, everyone.
All right. Take care, all.
Happy holidays, guys. Bye.
You too.
Bye. Recording, stop recording.